In this session, we will see about lining of irrigation canal and a problem related to it. The lining of irrigation canal is all about having a lining in the bed of the canal and also along with the side. So it's just because for avoiding any kind of a seepage losses or even to avoid the growth of weeds. So this is called as uh, the adopting of lining in the canal is called as the lining of canal. So if seepage loss is minimized with the help of lining of canal, then velocity can be increased. So that ultimately the discharge can also be increased without increasing the section at the same time. Right, and if you see the advantages, then it prevents seepage, waterlogging, silting and weed growth, and also decreases the rugosity coefficient, minimizes evaporation losses, and also provides a narrow cross section and flatter slope, and also provide stable banks against breaching. And if we consider the disadvantages, then that is the initial investment is very high, and also that it cannot be uh, used for berm, that you can't provide any berms here in case of this uh, lining of an irrigation canal. And also it is difficulties in repairing, and also it has some difficulties in shifting the outlet. And if you see about the type of lining, then we have hard surface lining, earth lining, and buried and protected membrane lining. So hard surface lining includes the cement concrete lining and shotcrete lining, precast lining, cement mortar lining, brick lining, stone blocks lining, and asphalt lining. And under earth lining, this includes soil cement lining, and also clay puddle lining and sodium carbonate lining. And under buried and protected membrane lining, so in this it includes prefabricated light membrane lining, and also bentonite soil lining and road oil lining. So this is the area and wetted perimeter of a lined canal. So here, considering the trapezoidal canal, so the area is A is equal to BD plus, so BD plus D square the theta plus cot theta. So similarly, the wetted perimeter is P is equal to B plus 2D theta plus cot theta. Right, and B is the base width of the canal, and D is the depth of the flow, and angle theta is the angle made by the side slope of the water surface. So moving on to the design of lined canal. So the data required for the design of lined irrigation canal are the discharge rugosity coefficient N, bed slope S, and limiting velocity V, and side slope Z ratio of 1. Right, and sometimes instead of V, the B by D ratio may also be adopted. So here the design procedure is, so under case 1, that is limiting velocity given, and for this the first one is hydraulic mean depth is calculated. So as usual, you're knowing that V is equal to 1 by N, R power 2 by 3, and S power 1 by 2. Right, so the same thing. And also we know the to find the area and the perimeter, so you're knowing that A is equal to Q by V, continuity equation, right? And P is equal to A by R, right? So the third step is the bed width and depth of the channel are found using. So we have only trapezoidal channel section. So here I'm ignoring the triangular channel section. For the trapezoidal channel section, so you are we already saw about the formula that is A is equal to BD plus D square into theta plus cot theta, and P is equal to B plus 2D into theta plus cot theta. So that is theta is the side slope. So this is for under case 2, that is B by D ratio is given. So you are already aware of the velocity, the formula that same, that B is equal to 1 by N R power 2 by 3 S power 1 by 2, and the velocity is also given. So you're knowing about the continuity equation, B is equal to Q by A, and also with this you can get the value. So that is area, you are substituting the area, and for a hydraulic mean depth you're knowing R is equal to A by P, and also you're knowing what is A and what is P, and then you can go for this step 2, that is to substitute the values of B by D is equal to X and the side slope and bed slope, and determine the value of bed width B and depth D. So actually the mostly the procedure is the same only, but only the area and the perimeter is quite different. Okay, so moving on to the problem, the design a trapezoidal shaped concrete lined channel to carry a discharge of 100 cubics at a slope of 25 centimeter per kilometer. The side slope of the channel are 1.5 is to 1. The value of n may be taken as 0.016. Assume the limiting velocity as 1.5 meter per second. So you're knowing the Manning's formula, so you can adopt V is equal to 1 by N, R power 2 by 3, and S power 1 by 2. And you are knowing to calculate S, so the S is the 25, so of 25 centimeter per kilometer, right? So you can have 25 divided by 1000 into 100, so you're having S is equal to 1 by 4000, and also V is also given, that is a limiting velocity as 1.5 meter, and N is also given 0.016. So with that you can find R by substituting in the Manning's formula. And then if not, then you can also have the channel section is assumed to be trapezoidal. So for side slope one and a half is to 1. Cot theta, you're knowing 3 by 2, 1.5, and theta is 0.59 radian. So you can check out the figure here. So that is side slope, and cot theta and the radian. So with the reference to whether the trapezoidal shaped or flat bottom channel. Okay, so the area of cross section of the channel, you're knowing A is equal to Q by V, and you can find out the value for A. And perimeter, so P is equal to A by R, and already we found R, so you can find it. And then you can also use the same, that is the area and the perimeter formula. You can just substitute it, and you can get the value. So the two equations, you can substitute the values and get the value for the dimensions. So here the required bed width is 26.68 meter and the depth is 2.15 meter. Now for the same problem. So when the limiting value of velocity is not given, but v by d is given as 8. So now we are knowing the formula for the area and other things, and you can substitute it. So design a trapezoidal shaped the same question, but here the limiting value of the velocity is not given, right? But b by d is given. So now you can substitute the value of theta and cot theta in equation 16.7. So the 16, so that is area, right? So the area is equal to bd plus d square into theta plus cot theta, right? So that is trapezoidal channel. So therefore the velocity in the channel, you can have v is equal to q by a, and get the equation, and also find the hydraulic mean depth, and again you can get the another equation with the help of it. By using Manning's formula, you can substitute it and get in terms of value, that is R and V. So you can substitute the values of R and V in this equation and deduce it and find the width and depth, right? So nothing much, only the area formulas are used, just the area and perimeter and Manning's formula solidly, right? And the continuity equation. That's it, the hydraulic mean depth. So the formulas doesn't change, but only the equations, what you are going to substitute it substitutions values, and also the what content is that. Here the b by d is given. So only that is, so the methodology of problem changes only when it comes to typical kind of a thing, like finding b by d, b and d values. And suppose if you're wanting to solve a triangle one. So for triangle, the area is A is equal to d square into theta plus cot theta, and vector perimeter is 2d theta plus cot theta, right? So with reference to this, procedure doesn't mostly won't change. Okay, so we'll see about one triangle problem here. So design a concrete lined channel to carry a discharge of 25 cubics at a slope of 1:2. 10,000, the side of the channel are 1 by 4 is to 1, and Manning's n may be taken as 0.018. So we are knowing the formula, that is A is equal to pi d square theta by pi plus 2 d square by 2 cot theta. So that is 2, that is d square into theta plus cot theta, right? So, and also you're knowing the perimeter. So perimeter is P is equal to 2 by d, right? And theta pi, and 2d cot theta. So that's what we got here, 2d theta plus cot theta, right? And you're knowing the formula for the hydraulic mean depth. So now you can adopt the A by P value and substitute it along with the Manning's equation and find the value in terms of theta in terms of radian. And simply what you can do is that you can substitute in the Manning's equations and find the value. You will get the D, depth. So mostly procedure doesn't change, that only that area and the perimeter value changes, okay? And accordingly you can substitute and find the values. So I hope you understand the lined canal.